For many years, the energy efficiency and environmental issues have been at the forefront of the electric car business. With their groundbreaking electric motors, which have garnered accolades for their unmatched performance, durability, and low-maintenance design, Tesla has been at the forefront of the industry. However, just when you thought things couldn't get any better, Tesla has once again pushed the envelope. Tesla's newest motor, which Elon Musk recently showcased, is already wreaking havoc on the industry. It's time to see how this innovative drive unit promises to transform the industry and redefine our perception of electric. Transportation forever. To begin our deeper discussion of these issues, please hit the like button to demonstrate your support for Wall Street profits, and the subscribe button from its inception, when it was first established as Tesla Motors and led by Elon Musk, who has served as the company's product architect from the start. Tesla has been creating its drive units. But Tesla has been able to stay at the forefront of the market because to its creative approach to engineering and production. With the launching of Tesla's model in 2012, the original Roadster, which was conceived nearly 2 decades ago, contained power electronics in a drive unit that was manufactured and designed by Tesla but licensed technology from Propulsion. At the time, this was the proof of concept. Today, the drive unit is entirely internal and does not rely on technology licensed from outside parties. 2 of the most cutting-edge and effective electric motors available are the permanent magnet and induction motors made by Tesla. One of the most popular electric motors on the market today is the induction motor, which Nikola Tesla invented in the 1880s. An induction motor generates rotating magnetic fields by the use of a number of electromagnets, which causes the motor to induce an electric current. This generates a force that turns the rotor and releases mechanical energy in rotation. Compared to other motor types, an induction motor's design is simpler and has fewer moving parts, which increases its dependability and low maintenance requirements. Conversely, a permanent magnet, unlike induction, motors employ a number of magnets to produce a magnetic field that interacts with the electric current and the rotor to produce motion. Because PM motors a fixed magnetic field, they operate more efficiently and generate less heat. They are therefore perfect for usage in electric cars, where dependability and agency are essential. For its Plaid vehicles, which comprise the Model S and Model X Plaid in addition to the Tesla Semi, Tesla has also created a new kind of engine. We're excited to see what Tesla has in store for the future of electric mobility, as the new motor promises to push the envelope even farther. When it comes to features that consumers can see, such power, acceleration, and low energy consumption or efficiency, Tesla has always been a leader in innovation. However, one of the most significant breakthroughs that sometimes goes overlooked is cost. It is extremely difficult to produce high-quality goods at low rates, yet doing so will make Tesla's technologies available to a wider audience. Despite the moniker being used in all of their vehicles, Tesla has already started cutting prices in their Model 3 engine. From 2017 to 2022, they lowered rare earth metals by 25%, eliminated 20% of the weight, and remarkably reduced the manufacturing area needed to make these motors by 75%, which contributed to a 65% cost reduction. Increasing the factory is another essential component of lowering the cost of the motor itself. At Tesla's recent Investor Day, car specialist Cindy Monroe and his team noticed that Tesla is using a hairpin electric motor design, which further improves efficiency and lowers cost. The cost of the factory itself often ends up within the cost of the product, since Tesla needs to charge enough to cover all of their expenses, rather than using round wire as in the past. This design uses rectangular wire, which fits more copper in the same area and makes the motor more efficient. Overall, Tesla is revolutionizing the automotive sector with its concentration on extreme volume and cost reduction while keeping high-quality goods. Hairpin motors are a relatively new technology that has gained traction in the automotive industry, in contrast to standard electric motors, which are an integral part of electric vehicles. Hairpin-shaped stator windings, which improve heat dissipation and reduce wind resistance, are a feature of hairpin motors that boost efficiency. Additionally, the increased copper fill factor made possible by these windings makes for a stronger magnet and, ultimately, a stronger motor. Tesla has joined a number of well-known automakers who have previously incorporated hairpin designs into their electric cars, including Volkswagen, BMW, and General Motors. Tesla can swiftly iterate through millions of designs to select the best one because to their bespoke software, which is quicker and more accurate than software from rival companies. Since AI can be used to optimize hairpin technology, this program is also ideally suited for it. The motor's overall efficiency is increased and its resistance is decreased by the hairpin windings arrangement. The accuracy of the copper hairpin bending and welding process is one of the main implementation issues for hairpin technology. In order to solve this problem, Tesla created automated equipment that is currently being used to assemble these motors. This is a significant advancement since improperly welded hairpin ends may result in electrical losses which lower the motor's efficiency. The Tesla charging chip is another example of innovation. Experts claim that Tesla chips are unrivaled in the industry. They have been able to cut heat by 2 times and the number of microprocessors from 4 to 1, making the chip smaller and requiring less silicon carbide and costly material. Tesla manufactures its high-level tips in-house. The tip represents a tremendous technological leap because it retains the same, if not superior, capabilities in spite of these alterations. At Tesla's Investor Day, the company demonstrated how its dedication to software design and vertical integration has allowed them to push the envelope of what is feasible in the electric vehicle market. Colin Campbell emphasized that Tesla is able to manufacture 100% of its high-level vehicle components internally, all while maintaining an organizational structure that encourages involvement and communication from all parties. In fact, hardware design at Tesla is carried out using software that has its roots in Silicon Valley. The announcement that Tesla's next-generation motor will use no rare earth metals was one of the event's most remarkable ones. The rare earth metals sector is now a little more uncertain as a result, and the stock prices of firms like MP Materials have dropped. It is a credit to Tesla's engineering prowess that they were able to eliminate these pricey and challenging to find materials without compromising performance. Previously, each drive unit contained 500 grams of an unidentified rare substance and 10 grams of 2 other metals. Tesla could not say which metals were dysprosium, praseodymium, or neodymium. Tesla's permanent magnet motor usually contains these metals. Long-term savings of hundreds of millions, if not billions of dollars, will result from Tesla's removal of rare hairpin-shaped stator windings, which lower winding resistance and enhance heat dissipation, are another feature of Tesla's next-generation motor. Additionally, because of the hairpin windings, there can be more copper packed into a given area, increasing the copper fill factor and producing a stronger magnet and motor. Tesla is joining the ranks of corporations like Volkswagen, BMW, and General Motors, who have previously embraced electric vehicles. Even though this technology is still being investigated, Tesla has been to improve its motors and cut costs in other areas because of their dedication to software design. Compared to rival software, Tesla's proprietary software enables them to model and simulate the complete motor, as well as its revolving electric field more quickly and precisely. Hairpin technology, which is now at the research stage, is a good fit for this. AI is also capable of optimizing the hairpin mining pattern to lower resistance in the motor and raise overall efficiency. Additionally, Tesla has been able to cut the amount of silicon carbide utilized in its high-level chips by 75% thanks to internal chip building. The motor's use of several chip types may be impacted by this reduction in chip size, but Tesla has been able to maintain interchangeability by reusing the inverter casings across all of their vehicles. All things considered, Tesla has been able to push the limits of what is feasible in the electric vehicle business thanks to their dedication to vertical integration software design and innovation. Although there are limits to Tesla's compatibility with its current designs, Sandy Munro and his team believe that the next-generation powertrain will enable Tesla to reduce costs and rework its components. The next generation drivetrain as a whole will only set you back $1,000, a substantial savings above what their rivals charge. According to Sam Corres of ARK Investment, the cost of a battery pack from a next-generation vehicle may be approximately $5,000 plus an additional $1,000 for the new powertrain. But given that the next generation vehicle would be lighter and smaller, the battery capacity utilized in this computation seems excessively huge. The response from the hedgehogs is that a 45 kilowatt-hour pack is more precise, costing $16,000 for the car and $4,100 for the powertrain. What makes Tesla so remarkable is that they do everything in-house. This distinguishes them from their rivals who are too busy outsourcing software and parts to keep up with them. More of Tesla's next-generation motor will be visible, and the majority